lesson 2.7, solving absolute value inequalities. What does absolute value mean? Think back, we talked about absolute value, we solved absolute value equations back in chapter 1. Cody?
It means x equals a certain number.
Well, that's kind of it. Julia? Distance from 0. If I ask you to give me the absolute value of something, I am asking you to tell me how far it is. What's its distance from 0? So absolute value actually means distance from 0. Does anybody remember what the symbolism is for absolute value? How do you know when they're asking you for absolute value? What does it look like?
Doesn't it have like parentheses?
They kind of look like parentheses, except they're just bars, vertical bars, aren't they? Yeah, just vertical like sticks is what they are. Around an expression, that means absolute value. So when you see those, they don't have the rest of it. They don't have it made into a brace or a parenthesis. It's just two vertical line segments, really, on either side of an expression. They're asking you for the absolute value of that. Or in other words, they're saying how far is it from 0. So today we're going to deal with, I want you to circle this, absolute value inequalities that have those two inequality symbols, is less than and is less than or equal to. So whenever the inequality that we're starting with to solve has those as its inequality symbol in it, those are the type we're going to talk about today. So when we have, right here, we have the absolute value of x, those are those absolute value bars. Absolute value of x is less than or equal to 2. What that really says is that x must have a distance of what? Less than or equal to 2.
Of negative 2 units from 0.
Do we have negative distance?
No. Like in a car, you can't have negative distance.
Yeah, when we back up, we don't talk about that we went a negative distance, do we? So x must have a distance of at most, excuse me. It can't be any more though. So we want it to be at, or here's the words I meant to use. I got three slots and I couldn't figure out what I wanted. No more than 2 units from 0. No more than 2 units from 0. The absolute value of x, whatever you put in here for x, it has to be its distance, that's what absolute value means, its distance has to be less than or equal to 2. So it can't be any more than 2 units of distance away. So basically what we're saying then is that, I think here's what Cody was saying, we have negative 2, that is 2 units of distance away from 0, am I right? Can it go out any further than that? And what's the furthest it can go out to the right from 0? 2, positive 2. So what we're going to do is we're going to put x in the middle. We're going to put negative 2, how far it can go to the left. No more than 2 units away. How far can it go to the right from 0? No more than 2 units away. So we say is less than or equal to, is less than or equal to. There's our compound inequality that we set up. That's how we get rid of those absolute value bars. If you remember right, when we were solving absolute value equations, here's what we would have done. We would have said, oh, the absolute value expression is by itself, so I'm going to set x equal to any numbers that have a distance of 2. So we set it equal to negative 2 and positive 2, and then we solved it. Well, we have inequalities this time instead of equations, so we have to set up a compound inequality instead. Okay? So that's how we got rid of the absolute value bars. Okay, let's look at the next one. The absolute value of 3x is less than or equal to 9, says 3x must have a distance, oops, need a pen, must have a distance of no more than what?
3.
3 units from?
9.
From what?
9.
No, from 0.
0.
Okay, that's a distance of no more. Excuse me, you are so right. I am wrong, Noah. There is a 9 over there. I apologize. No more than 9 units from 0. 3x must have a distance of no more than 9 units from 0. It has to be less than or equal to 9. Therefore, what do you think we can do to drop those absolute value bars? What compound inequality do you think we can set up? Go ahead, we'll let you finish, Noah, since you caught my mistake.
Like at the top of the negative 2x less than or greater, like that.
Mm-hmm. Yep.
Would be 3. Negative 3 is less than or
No, remember what it said. It says the distance of 3x. So what should be in the middle?
3.
3x should be in the middle. Its distance can't be any more than 9 units from 0.
Also negative 9.
So is, yeah, so negative 9 over here and
Negative 9 on the other side.
positive 9 over here. Because in other words, starting from 0, if you go 9 units and no more than 9 units, the furthest out you can go is negative 9. If you come back to 0 and you go no more than 9 units from 0 that way, you can't go out any further than positive 9. So 3x, what's in absolute value bars, has to be somewhere between negative 9 and positive 9. Okay? Now, that is not actually solved yet. All we've done is just written the inequality we can write here, the absolute value bars. Here's the thing that was so hard for you guys when we were solving absolute value equations back in chapter 1. You didn't get rid of absolute value bars, you would start doing the work right away. You have to get rid of the absolute value bars, and then we'll do the work solving that we've been doing now for the last few days. So, to solve, get the absolute value part alone. You can't have anything happening on that side with it. Nothing can be being added to it, subtracted from it. It can't be getting multiplied by anything. It can't be getting divided by anything. So, I am not doing a good job of looking at my notes. Erase that. Get the absolute value part by itself, which is alone. By itself. I didn't see that I carried this on to the next line. Get the absolute value part by itself. Then, set up the and compound inequality. That's the kind we're going to be setting up today because it's going to say is less than or is less than or equal to. And then finish solving it if it isn't just x in the middle. So what that means like this. So this is an and compound inequality, isn't it? Is that an and compound inequality? X is by itself. It doesn't need anything else done to it. Here we set up the and compound inequality. Would we have to do another step in this one?
Divide.
Yeah, we'd have to divide every region by 3, wouldn't we? Okay? So, let's start solving them. Let's start practicing actually solving them. Number 1, the absolute value of 5x is less than or equal to 15. What's that say? 5x must have a distance of 15. No more than, or less than, or exactly? Jossie? Do what? Can you just say it? So I want to answer this question though. 5x can have a distance of no more than 15. Okay, so we're going to set up a compound inequality that says that. So Jossie, what is the compound inequality?
Negative 15 is less than or equal to 5x is less than or equal to 15.
Okay, good. No absolute value bars anymore. We've now said 5x can have a distance of, you can go out to negative 15 because all those numbers have a distance of 15 or less, no more than 15. And it can go out to positive 15 because all those numbers have a distance of 15 or less, no more than 15. Yes, okay, Noah, what?
When we began, it said with the bars, are we going to use the same symbol always as we did, not writing with the absolute value bars?
Okay, so you're saying we're not going to have absolute value bars.
Or we're going to use the same symbol?
Are we always going to use these symbols?
Is it going to be the same symbol every time?
It depends on whether what's in the equation that's given to you.
I'm not sure I quite understand your question yet, so can we put your question on hold for a bit until we do a few more, and then maybe you'll even answer your own question?
Yeah.
Okay? Because Because I'm just not clear what you're asking me right now. Okay, so do we have to solve this one or is it already solved? We have to solve it, don't we? It isn't just x in the middle, it's 5x. So what are we going to do? Divide every region by 5. So negative 15 is going to get divided by 5. Would you do it on a separate? Don't just put those fraction bars there. You're not going to see that first thing we had to do. That's the first thing we have to do. Now we're on the second thing we have to do. So 5x is going to get divided by 5. It must be Monday. And 15 is going to get divided by 5. Each region gets divided by 5. Cody, what are you doing? Negative 15 divided by 5 is? Negative 3. Okay, so we're saying negative 3 is less than or equal to what's in the middle? Just our x is less than or equal to what's 15 divided by 5?
3.
Positive 3. Okay, there's our solution algebraically. And now we're graphing. So what does this graph look like? We have our two endpoints, negative 3 and positive 3. Do they have open circles or shaded in circles at them?
Shaded.
At both of them? Okay. One thing about solving absolute value inequalities, both of your endpoints will always have the same behavior. They'll either both be shaded in or they'll both be left open. And then where are all the numbers that x can be? In between. All these guys in between are solutions also. So negative 3 and positive 3 and anything in between would make that absolute value inequality that we started with true. Okay, notice we were able to go right to setting up the compound inequality without the absolute value bars in it because the absolute value expression 5x was already by itself. Is that true in number 2? Can we go right to setting up the compound inequality, do you think? What do you think, Devante?
No.
No? No? What do we have to do then?
Add 7 on those.
Yeah, we can get that 7 out of there, don't we? We got to add 7 to both sides. So we have to get the absolute value expression by itself. So we're not ditching the absolute value bars yet. We are just getting rid of that 7 that's not part of the absolute value expression. Now the absolute value expression is by itself, and it says the absolute value of x is less than 10. And if the absolute value of x is less than 10, what does that mean? The distance for x has to be what?
Less than.
Less than 10. Can it be 10?
No.
No, can't be 10. So it can be up to 10 units away. So what compound inequality can we set up for this?
Negative 10 is less than x.
We call that in. Chelsea?
Negative 10 is less than x is less than 10.
Okay, we can ditch the absolute value bars because now we can set it between the two numbers that have a distance of less than 10, negative 10, and positive 10. In between those are all the numbers that have a distance of less than 10. Do we have another step to do to get x alone?
No.
No, we actually have our solution right here. We already have it. And we're ready to graph it. Open or close circles?
Open.
Open, because these guys are not included. They're too far away. They are not less than 10 units away. They are 10 units away. But all those other numbers are not. Now, be really careful here. Here's what your brain is already starting to do. At one end, there's a negative number, and at the other, there's a positive, and they're opposites of each other. That happened both times, didn't it? Okay. That does not have to be the case always. So don't let your brain do this. Just automatically say, if I get a negative 10 over here, that means that the opposite at the other end is going to be the opposite number. We have to be really careful about that. Okay? We have to actually work it through and see what actually happens. Okay? Let's go to the back then and practice a few more here. What would be our first move in this one? What would be our first move? Tori, what do you want us to do?
Subtract 4.
Subtract 4. Can we get rid of the absolute value bars yet, or just subtract 4?
We can just subtract.
Just subtract 4.
Yeah, we just want to subtract the 4. The absolute value bars are still going to be there. Absolute value of 2x is now by itself, and we have 10 on the other side. Now, Calvin, what are we going to do? Considering what that says the distance of 2x has to be less than or equal to 10. Abby, can you help him out?
Is less than or equal to 2x, and that's less than or equal to 10.
Okay, good. Absolute value bars are ditched now. We've set 2x between negative 10 and positive 10 because those are the numbers that have a distance of 10 or less. And now what would be our next move in this one, Aurora?
Divide all of them by 2.
Divide every region by 2. Yep, divide all of them by 2. And what's the result from that, William?
Negative 5 is less than or equal to x, less than or equal to
Okay. Are we done? Is x by itself in the middle?
yeah, we need a graph.
Okay, so yeah, there's our solution algebraically, and now we just need the graph. And I just said to you, don't count on them always being opposites. Did I lie to you? Oh my gosh, it happened again. I hope I didn't. Try not to lie. Okay, why don't you try the next one on your own, see what happens. Go for it. Try it on your own. I'll work it up here silently by myself, and you are working in pencil, so if it doesn't go well for you, you can look up and change it any part you need to. You are working in pencil. When you are done getting the algebraic solution, before you graph it, you want to see if you and I agree. If we don't, see if I made the mistake or you made the mistake. Anybody in agreement with me? Got the same solution I did? Yeah? Okay. Majority of us? Okay, so we can go with it. Okay, and then we can graph it. So here's one of those that just proved that I was telling you the truth. Are these guys opposites of each other, negative 16 and 4?
Yes.
Negative 16 and 4 are opposites?
They're opposite, like positive and negative.
Yeah, it's got opposite signs, but they're not opposites, because what's the definition of opposites?
The same number but different signs.
Different in every way.
Let's give me a really good definition of opposites. Numbers that are the same distance from 0. Numbers are the same distance from 0. So can these guys be opposites? No way, they're not the same distance from 0. Okay. Do we shade those guys in?
No.
No, because the equal to bar was not included in this one. So all the numbers between negative 16 and positive 4, when substituted back into our absolute value expression, should make it true. If we were going to check it out. Okay. Anybody have questions on that one? Because it's, before we move on. Okay, how about number 5? What do we get to, what step do we get to skip this time?
The adding, the adding for those values.
Yeah, we get to skip getting the absolute value expression by itself. It's already by itself. There's nothing else happening on that side of the absolute value bar. So what are we ready? What are we going to go right away to doing? Jossie?
Absolute value.
Making the shoot, what do you call it?
The compound.
Inequality.
Yeah, writing in our compound and inequality. So what's it going to look like? How's it going to be?
Negative 10 is less than or equal to 2x minus 4 is less than or equal to 10.
Okay. We need to ditch those absolute value bars, set up our compound inequality. That says, you know what, its distance has to be somewhere between negative 10 and 10, including those guys, so inclusive of those guys. And now, what's our first move?
Add 4 means to both tens.
Add 4 to
Negative 10 and 10.
all
three.
three regions. Add 4 to all 3 regions. Okay, and then we will have, what's the left region going to be now? Negative 6 is less than or equal to, what's the middle region going to be?
2x.
2x. And what's the right region going to be? 14. Okay. Are we done? No. What's our next move?
Dividing both, all 3 regions by 2.
Divide all 3 regions by 2. So negative 6 gets divided by 2, our 2x gets divided by 2, and our 14 gets divided by 2. So, Michaela, read for me what our solution is.
Negative 3 is less than or equal to x, that is less than or equal to 7.
Okay, we're done solving, and we're ready to graph it. And again, how do you feel about those endpoints? Are they opposites of each other? No, so we can't just get lazy and assume, solve the left region and say, you know what, well the right region will be its opposite. Not always. We have to go through the process of solving to make sure that we end up with what we should. Okay, how about our last one here, number 6? What's going to be our first move? Devontae, what's your first move?
Subtract 1.
Okay, from
Both sides.
both sides. We don't have compound inequality yet. We don't have to worry about 2 regions yet. Okay, now we have our absolute value expression x plus 5 by itself, and it can't be any, it has to be less than how many units away from 0? 5. Okay, so are we ready to set up our compound inequality?
Yes.
Okay, so it's going to be negative 5 is less than x plus 5 is less than positive 5. What kinds of 5s going on in this one? Okay, next move.
Minus
5
5.
from all 3 sides.
Do you have a question, Joss, or you just want to tell me what to do? You were raising your hand like I'd like you guys to do. Okay, so we're going to subtract 5 from every region.
All 3.
All 3 of them. Negative 5, take away 5 more is?
Negative 10.
Negative 10. X is by itself in the middle. 5 take away 5. 0. Do we need to put that 0 there?
Yes.
Absolutely. 0 is a number on the number line too. It can be an endpoint. So don't let that fact that it's nothing's left there mean you just get to drop it off. 0 is your other endpoint. Okay, and shaded in between them. Okay? So when this really starts getting tricky is when you have to decide what kind of compound inequality you should set up. Today, we're just going to practice these kind. So what should happen today is what happened in our notes. The only types of problems that you should come across, I should have chosen for you ones that this will be the situation. Okay? Anything unclear yet that you have a question about? Did you ever answer your question, Noah, in the process of doing these?
I figured it out.
You figured it out, good. Okay. Okay, then I'll let you get to work on homework.